Okay, we're continuing on here. 54. Got p to the minus 3 divided by p to the 5th. So we can do quotient, which says that if you have a quotient with the same base, that you subtract the values in the denominator from the values in the numerator. So this is 5 in the denominator, so I'll subtract it. So negative 3 minus 5 is negative 8. But then I rewrite this, moving the p to the negative 8, move that to the denominator and change the sign. Okay, then we got 57, 7k squared, negative 2k, 4k to the negative 5 power. So you're going to treat the constants and the exponent terms separately. So what we do is, basically we have 7 times this, times this, times that, times that. Let me just write out what we really have. 7 times k squared times negative 2 times k times 4 times k to the minus 5 power. So it looks like we might have 3 products, but really we have 6 products. This times that, times that, that. Now you can rearrange these things because you're just doing straight multiplication. So I can put all the constant terms together, and then I can put all the exponent terms together. So here we have one negative sign, so that's odd. So my answer is going to be negative. And I multiply these numbers together. 2 times 4 is 8. 8 times 7 is 56. Then I have k, and we're multiplying everything together, so we add the exponents. We have a 1 exponent there. If there's no exponent, assume to be 1. So you get 2 plus 1 plus a negative 5. So we get negative 56k to the negative, what is it? So 2 plus 1 is 3. 3 minus 5 is negative 2. Can't end with a negative result, so we have to rewrite this, moving the k to the negative 2 power to the denominator and making it positive. Okay. 60. p to the negative 1, whole thing cubed times p to the 4th, or negative 4th. So the order of operation says that we need to do what's in the parenthesis first. And this, so we're going to look at this term separately. First, we're going to do that. So when you have an exponential expression itself in parentheses raised to an exponent, you multiply them together. So the result here is going to be p to the negative 1 power times 3. And the second term we don't do anything with yet. So we multiply these two exponents together. Negative 1 times 3 is negative 3. Now we have a product of two exponential functions. So you add the exponents together. Negative 3 plus negative 4. And negative 3 plus 4, negative 4 is p to the negative 7. Remember on the number line, here's 0. We're starting at negative 3, and we're adding a negative 4, so that means we go 4 in the negative direction. That gets us to negative 7. Okay, are we done? No, because I have a negative exponent. So I'm going to move that to the denominator, make it change from negative to positive. Okay, 63. We have 3a to the minus 2, the whole thing raised to the third power, times a cubed to the minus 4 power. So we actually, over here we did this separately. We're going to have to do each one of these separately. We're going to do this one here, and we're going to do this one here. So here we have a product of two terms, 3 times this. If you have a product of two terms, it's like you're doing this thing outside the parentheses to each term. So you're going to have 3 cubed times a to the minus 2 cubed. The rule says a times b to the x. It's the same as a to the x times b to the x. So that's what I've done. Okay, I'm not going to do the second part yet. I just wanted to get it. Okay, now at this point, we use the exponential rule, which says if you have a term in the parentheses raised to a power, you multiply the exponents together. So we're going to have a to the negative 2 times 3. So this is the operation we carry out first. And the same thing over here, you're going to have a to the third times negative 4. Too many times do people add these together. The only time you add exponents together is when you just have the terms raised to some power, simply. But when you have a parenthesis and an exponent outside, you have to do that first. Okay, so we got 3 cubed times a, negative 2 times 3 is negative 6. Negative 4 times 3 is negative 12. Now it's in the point where we just have an exponential term without any parentheses. This is a product, so we're going to add the exponents. So negative 6, adding a negative 12. That's going to be even more negative. So we add 6 and 12 and make it negative. So you're going to have 3 cubed a to the negative 18 power. Now we always have to go ahead and multiply out any constant raised to a power. We just want a single number or a single rational number. So that's going to be 3 times 3 times 3. We're going to move this to the denominator because it's a negative exponent. So 3 times 3 is 9. 9 times 3 is 27. So I get 27 divided by a to the 18th power. Okay, moving on, 69. We're converting to scientific notation. You guys who took the first semester, hopefully you know what to do here, but basically what we do is you want a number, I think we talked about this first semester, but what you want is a number between 1 and 10, so you change this number to 2 point something, 2.30. You multiply by 10 raised to a certain power. The power is how many times you have to move your decimal point from your normal location. So the decimal point here is normally right there at the end of the number. To make that 2 instead of 230, you should move it 2 times. And what that means is you have 2.3 times 10 squared, which is 10 times 10. So you get 2.3 times 100, which is 230. So this exponent allows us to have a long number with lots of zeros in a much more compact form. Now, in the other direction, if you go to the other side, a small number, a fraction between 0 and 1, you do the same kind of thing. We want to change this into a number between 1 and 10, which is 5.1. If we did 0.51, that's not between 1 and 10. If we did 51, that's not between 1 and 10. So it's always a number between 1 and 10. You can figure out where to put the decimal point. And then what you do is you count how many decimal points you have to do to get to that point. So you go 1, 2, 3 to get the decimal point here to make it 5.1. When you go to the left, you do it to negative exponents. So it's 10 to the negative 3. So what this is saying is it's 5.1 times or divided by 10 cubed. So if you move this to the negative exponent to the denominator, you get 5.1 divided by, in this case, 10 to the third, which is 10 to the third is 10 times 10 times 10, which is 1,000. And if you plug that in your calculator, you get that. Also, what you can do is you can to get 1 in the denominator, you have to go 1, 2, 3 decimal points. So you go 1, 2, 3. You'd have to add 2 zeros to get 3 decimal points. So it does move this 3 decimal points, which is basically dividing that by 1,000 in the same way here. So I moved it to 1. I don't have any numbers, so I've got to add a 0 and another 0. And any number divided by 1 is just the number. So that's kind of the idea behind scientific notation. It's a way to represent large numbers. Now it turns out a large numbers and small fractions, small decimal numbers between 0 and 1 with a lot less zeros. So I'm just going to do an example here with a lot of zeros. So let's say I have 0.0000000000092. That's a heck of a long number. But if I were to write this as 9.2 times 10 to some power, what power would it be? Well, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 10 to the negative 11th power. So you see that's much more easy to look at than that. You're much less likely to put in the wrong number of zeros. It's easier to type negative 11 than it is to count all these things. Okay, 74. So to go the other direction, if you're given a number in scientific notation, how do you deal with that? Well, what you do is you write the numbers down without the decimal point in there, like that. You start here with the decimal point, and then you go to the right however many digits is shown by the exponent. So you go 1, 2, 3. Well, there's no number there, so I have to add a 0, 4, add another 0. There you go. So the original decimal points here with the exponential notation, I go 1, 2, 3, add 2 more zeros to get 5. And so that's 231,700. So that's how that works from a large number standpoint. From a smaller number standpoint, I didn't actually assign it, but I'm going to show you here. 76 is 1.63 times 10 to the minus 4. So you'd write 163 start here where the original decimal point is, and then move the other direction for you. So you get 1, and you say, well, I can't move now because I don't have a 0, so I'm going to add a 0. Let's just add a couple of zeros, and then we can put the decimal point here. Okay, so it's here. You go 1, 2, 3, 4. Put the decimal point, and that is your answer. Okay, 75, 78. Okay, I think this will be the last one I do here. Now, we got these quotients with scientific notation. So you go 0.002 times 3,900 divided by 0.000013. It says, use scientific notation to perform each of the following computations. Leave the answer in scientific notation. So this actually was very valuable back in the days when you didn't have calculators and you had to do the multiplication in your head or on paper. So I'm going to just demonstrate this. So what you would do is you would rewrite each of these terms in scientific notation. So you want a number between 1 and 10. So here you start with 2, so the only number between 1 and 10 that starts with 2 is 2. And then you go 1, 2, 3. So that would be 10 to the minus 3 power. So you read the first number is 2 times 10 to the minus 3. Okay, the next number, what number between 1 and 10 has the numbers 3 and 9, so 3.9. 3.9, okay, so you start here and you go 1, 2, 3. So it's going to be 10 to the third. 10 to the third is 1,000. 1,000 times 3.9 is 3,900. Okay, then you divide by this number. What number between 1 and 10 has the first digit is a 1 and the second digit is a 3? Well, 1.3. Start here, 1, 2, 3, 4, 5. So since it's going the other direction, it's 10 to the minus 5. So, because this times that, times that, times that, divided by that, times that, it's all just pure multiplication and division. So what you can do is you can regroup it. So you do the constant stuff separately. And over here you do all the exponential stuff. Notice they all have the same base. So if I kind of combine the product and quotient rules, I have 10 to the minus 3 power plus to the positive 3 power. And then I'm going to subtract what's in the denominator, which is negative 5. And over here, I just can plug this in my calculator. I can do it by hand, so let me just do it by hand just to show you. So you take 3.9 times 2.09. So the first terms, you get 0 times 0, so that's 0. Then you go to the next number, and you'd say, okay, I have to put another 0 here because I'm in the next digit over. So you have put a 0, then 2 times 9 is 18. Carry the 1. 3 times 2 is 6, plus 1 is 7. You add these together, you get 0, 8, 7. I've got two digits to the right of the decimal point, so I put my decimal point right there. So I get 7.8. That makes sense. 3 is about 4. 4 times 2 is 8, so it's a little bit less than 8. Okay, then I would take 7.8 and I would divide that by 1.3. So what I do is as I rewrite this, I move the decimal point to the right in both the terms in the division. So now I'm just doing whole numbers. Okay, put a 0 here. How many times does 13 go into 78? 5, 6 times. So let's try 6 times 3 is 18. Carry the 1. 6 times 1 is 6, plus 1 is 7. So the answer is 6. Okay, so all of this stuff just gives me 6. And then I get 6 times 10 to the, well, I've got -3 plus 3 is 0. I've got a negative of a -5, so I get 10 to the 5th. So the answer is 6 times 10 to the 5th. And then I could rewrite it in non-scientific notation. If I wanted to, I'd take my decimal point here, 6 point, and I'd move it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and so the answer would be 600,000. And if I didn't, use the scientific notation, what I would have is 0.002 times 3,900, and I would do that, and then I'd have to divide by this number, and it gets really crazy. So that's why scientific notation was great. Back in the old days, of course, you can just plug that into your calculator and you'll get the answer. Let's just try it. 0.002 times 3,900 divided by 0.000013, and I get 600,000. Okay, I think that was the last one I was going to do, for this group.